PL2 act trio, yani this function calls a function to plot or visualize data. Exercise 1. Softmax converts a vector to a probability distribution by normalizing each element with the exponential sum. This code, the code compares my softmax with TensorFlow's softmax by applying both function to the Z array and comparing the results. This code PLT point close all closes all open plots, and PLT softmax my softmax likely plots the softmax output from my softmax using matplotlib. This would visualizing the result of applying the softmax function to the input data. This code x, y equal to load data loads the dataset where x typically represents the feature input data and y represents the label sergeant values. This is commonly used in machine learning for training models. This line prints the first element of the dataset x. It shows the input data for the first sample in the dataset. X0 access the first entry, usually a feature vector from x. Y0, 0 prints the first label, and y-1, 0 prints the last label. This line prints the shapes of x and y. X shapes shows the dimension of the feature data. Y shapes shows the dimension of the label data. This code, first one, silence feature warnings, and second one displays 64 random 20 by 20 images in a grid. Third shows the label for each images as the title. Exercise 2. This code creates a neural network with first one input layer for 100 units, second one to hidden layers 25 and 50 units, relay activation, third one output layer 10 units, linear activation. Next code, model points summary displays a summary of the model architecture, including the layers, their output shapes, the number of parameters, and the total parameters in the model. This code runs a unit test on the model, checking if it can handle inputs of shape 10, 400. It likely verifies the model structure and able to process 10 samples, each with 400 features. This code, this line extracts the individual layers of the model. Layer 1 refers to the first layer, input layer. Layer 2 refers to the second layer, first hidden layer. Layer 3 refers to the third layer, second hidden layer. These codes retrieves and prints the shapes of the weights and biases for each layer. W1, B1 weights and biases of the first layer, W2 and B2 weights and biases of the second layer, W3, B3 weights and biases of the third layer. It prints the shapes of the parameters to understand the structure of the model's learned components. This code completes the model with a loss function and Adam optimizer then trains the model for 40 epochs using X and Y. Plots loss TF history, plots the training loss over the epochs from the history object, visualizing how the loss decreases during training. These code predictions displays the images at index 1050 from X predict the class of the reshape images prints the prediction and the class with the highest probability. This code applies softmax to the prediction, prints the probability vector, and shows the total sum. MP argmax prediction P returns the index of the highest probability in the predictions, which corresponds to the predict class. This code displays 64 randomly selected images in an 8 by 8 grid, along with each image's true and predict labels. In summary, first one, random images selection. Each image is reshaped to 20 by 20 pixels and displayed in grayscale. Second one, prediction process. A neural network model makes a class prediction for image. Third one, Label display the true and predict. Labels are shows above each image. Finally, the answer grid is displayed on the screen. This code calls the display errors function with the model x and y parameters to get the number of prediction errors made by the model. It then formats and prints a message showing the error counts and the total number of images as y errors out of x images. Thanks for listening.